In this video, we'll see two examples of the type that we started in the last video, where we start by knowing how to write 1 over 1 minus x as a power series, using the geometric series example that we know, and using that power series representation of a function to write other functions as power series. So here's our first example. Let's express x cubed over 2x minus 3 as a power series. So what did we do in the geometric series example, in the other examples from the last video, is we wanted to write our function as 1 over 1 minus something. So you can't always do that. But you can write your function as maybe something else times 1 over 1 minus something. Okay, so this is not quite something times 1 over 1 minus something. For one thing, we have 2x minus 3. We don't have 1 minus something. So one thing we can do is factor out a minus 1. Now we have 1 over minus 3 positive 3 with this minus 1 minus 2x. And we don't want this 3 here, so we can do what we did before and factor it out in a previous example. So we have minus x cubed 1 over 3 times 1 minus 2x over 3. Okay, so rewriting a little bit. Negative x cubed divided by 3 times 1 over 1 minus something, 2x over 3. So now we know how to take this function and write it as a power series. We can think of this as 1 over 1 minus y. Writing this function as a power series is a sum from n equals 0 to infinity of y to the n. Here, y equals 2x over 3. So we get is minus x cubed over 3 times a sum from n equals 0 to infinity of 2x over 3 to the n. So we can rewrite that a little more nicely. We still have this minus x cubed over 3 times a sum from n equals 0 to infinity as 2 over 3 to the n times x to the n. And the normal thing to do with power series is to put everything inside the series. So what do we get here is we get a sum from n equals 0 to infinity of, one way to say it is minus 1/3 times 2 over 3 n times now x to the n. We're multiplying by x to the third. So we get x to the n plus 3. OK, so this is one way to write this as a power series. And then we want to know, like, when is this valid? So this is valid whenever that power series converges. And again, you can do the ratio test to see when this series converges. But we can also just use the fact that we know when the geometric series converges. So we use this power series representation of 1 over 1 minus something. So we need that something, 2x over 3, to have absolute value less than 1. So this is valid when absolute value of 2x over 3 is less than 1, which is the same as saying that 2x over 3 is between minus 1 and 1. Or that minus 3 over 2 is less than x is less than plus 3 over 2. So this is valid when x is in the interval from minus 3 over 2 to plus 3 over 2. This is a power series centered at 0. So you can think of it as 0 minus r, 0 plus r. R is 3/2, is the radius of convergence of this power series. All right, so I'll pause and erase, and we'll do another example. For the last example of this video, we're going to do a simple one. We'll write 1 over 1 minus x as a power series. Why is this simple? Because it's easier to just write 1 over 1 plus x as 1 over 1 minus something. 1 over 1 minus x. And now If we think of minus x as y, the power series representation we get is y to the n, or minus x to the n, which we can factor as a sum n equals 0, infinity of minus 1 to the n, x to the n. So here's our power series representation of 1 over 1 plus x. But when is this valid? This is valid when we want to use the power series representation of 1 over 1 minus something. We need that something to have absolute value less than 1. So we need absolute value of minus x to be less than 1, which is the same as saying absolute value of plus x is less than 1, or that x is between minus 1 and 1. This is valid when x is in the interval from minus 1 to 1, which is an interval centered at 0, where this power series is centered, with radius of convergence 1. So what we've seen so far are a bunch of examples of rational functions, something over something, where you can write them as power series using the fact that we know how to write 1 over 1 minus something as a power series. So these functions, representations of these functions as power series, all come from starting from the one key example of geometric series. So what we'll see in the next video is that there are certain operations you can do to a function, differentiation and integration, that you can also do to their power series representations. So we're going to start with some functions that we can represent as power series. We're going to differentiate and integrate, and that'll let us write other functions as power series.